Hey there, team. So I hope you're excited for this week. What we're going to do this week is we're going to cover a lot of the analyses that we've already done, but we're going to kind of put it all together. So this is an overview of what we've been doing the past few weeks. This process will really help a lot of you really start to put these analyses together to understand why we're doing what we're doing and get the better picture and hopefully help solidify what we've learned so far. Then once we've gone through and done this overview, we're going to repeat some of these analyses, but we're going to do it through AI instead. And then we're going to see how AI does for you compared to Stats IQ. So for this module, we're going to download the Qualtrics survey here and import that into Qualtrics. Here's a Qualtrics data set that you'll then import into that survey. And then this is another version of the data set that we'll be using for AI later on. So if I've downloaded all of these, they're going to show up in my downloads folder, and I can log into uvu.qualtrics.com. I can go to create new project, going to select survey, and then down here on the right, I'll click get started. Name the project. We're doing a Star Wars thing, so I'm going to say Star Wars film. That works with Star Wars film, whatever you want. Instead of doing a blank project though, we're going to import QSF. We're going to choose a file. It's going to show up in our downloads folder, no matter what kind of type of computer you're using. It's going to be in your downloads folder. And then I'll click Star Wars film.qsf, open that, and then go to create project. I'm going to let that load. Here it is. So for this, this is a survey, and the idea behind this data set is that you've been asked to analyze it, to look at what type of customers are going to purchase the highest number of tickets for the next Star Wars film. And so these are some of the questions. This was actually part of the final exam that I had in semesters prior, before I revamped this course. So it's just a fun little example, but how frequently do you play Dungeons and Dragons? Participants were asked that. How frequently they play sports, how frequently they worry about whether others think they're a nerd, who their favorite Star Wars hero is, what their gender is, and what their age is. And also, if you go to the survey flow, there's SW tickets, which was the number of Star Wars tickets that they purchased for the last film. So this is a data set that we're going to be using. But after I have the survey going, I'm going to need to go to data and analysis, because as of right now, my data is empty. I don't have any data. And then once that loads, I'm going to go here, click export import. I'm going to click import data. Going to select choose a file, and guess what? If I downloaded it from the assignment, it's in my downloads folder. I don't want the Star Wars AI. I want the Star Wars Qualtrics data. So I click that and I click open, and then I click upload. And then it shows me how those values are going to be mapping, and I select import responses. And then it can take a little bit for this to import all the responses. Looks like there's 99 out of 99 are successfully imported, but they're not going to show here until it's loaded them successfully. So you can refresh the page a couple of times. You see they're kind of starting to come here. I have 0 of 99 coming in. Refresh the page quite a few times until we see all the data here in the table below, and it shows up here that we have all 99 showing. This one's taking a little bit longer, but I can see they're going to come up probably after I refresh this. It can take a couple minutes. Boom. Okay. I do want this still tells me it's not finalized. I'm going to give it one more refresh. And there we go, recorded responses 99. I see all the data here. Okay, now that I see that, I'm going to click Stats IQ. I'm not going to click Stats IQ until everything's loaded, or because Stats IQ is horrible and very, very slow at updating. So now that everything's there, I don't have any data to update anymore. Now I'm going to click Stats IQ. and then just give this a few minutes to load. Okay, now it looks like it's loaded for me. I have no analyses yet. So I'm going to pop over to the assignment and let's take a look at a few things now that that's all loaded and ready to go. So first of all, in the last video from last module, I showed you this overview table. I wanted to give it to you here again. This is going to be very valuable. Even though Stats IQ and even AI oftentimes are going to, for the most part, run the correct analyses, we need to know how to look at these analyses. And honestly, AI is going to make mistakes, and we may see some of that today. Sometimes it's going to run the wrong analysis, and it's going to lead to misinterpretations. And so this gives us a really nice foundation on, okay, if we're looking at relationships between variables, this is a type of analysis I'm going to be conducting, and these are what the results are expected to be like. So for instance, if you're doing a chi-squared between two categories, your input and your output are a category, then you're dealing with counting. So what percentage of males purchased a purple car? And what percentage of females purchase a purple car? Is there a difference, and is that difference significant? What's the p-value, right? P-values are going to be part of all of these. If your input is a category, like let's say gender again, that's an easy one, but your output is a number. What was the average amount of money that males spent, and did that differ from the average amount that females spent? So money spent could be your output, and that would be a number, and you'd be dealing with averages and p-values. But if you have a number for your input and output, so let's say how much money you spent and how much time you spend using a product, okay? So maybe the more expensive the product is, the more time you spend using it. Maybe you value it more, I don't know. So in that case, you want to know, is that relationship significant? Is it positive or negative? Maybe the more money you spend, the less time you spend with the product. I don't know. And so you'll be looking at a beta to tell you whether that relationship is positive or negative, and a p-value as well. But if your input is a number and your output is a category, really Stats IQ and oftentimes AI is going to kind of put these results as if it was a t-test or ANOVA. And so you'll be looking at it very much the same way. But really you want to know, okay, as my input gets higher, let's say that the more money I spend on a car, is it more likely to be a Ford or a Dodge? And while traditionally that you're going to be dealing with betas here, the less traditional, more current thing going on in Stats IQ and AI is this is going to give you an average. So what's the average amount for a Ford? What's the average amount for a Dodge? Is a p-value significant? If so, then you say, okay, there is a relationship between how expensive the car is and the brand, such that the more expensive it is, the more likely it is to be a Ford versus a Dodge. So now we're going to run through some analyses that'll help us apply this table a bit more. So let's look at question 1. So using Stats IQ, which variables below predict SW tickets, or the number of tickets they purchased in their last film? Popping over to Stats IQ, let's take a look at these variables. So here I have numbers here for D&D. This is a number. We've got 1, 2, 3. So this is a number. We have another number, another number. Right here we have dots instead telling us this is a category variable, another category variable. And then we have this bar chart tells us it's a number as well, and a number as well. So we have these 3 are numbers, and the bottom 2 are numbers, so a total of 5 numeric variables. And then we have these 2 category variables. And this question 1 is asking us which of them predict SW tickets. So if we remember, by default, Stats IQ is going to have this key indicator be the output. All right. So if I want to know which ones predict SW tickets, that means what inputs are going to predict SW tickets as an output. All right, so I can come down here and I want to make sure the key is on SW tickets. And then if I zoom back out here, I can click relate. and it's going to tell me which ones predict SW tickets. And for that first answer, you can really just go off sentences. So for instance, SW tickets is strongly positively correlated with Nerd Worry. And these sentences will tell you if it's not a significant relationship, it'll say not a significant relationship. So that first part, you can very easily go through and answer just from the sentences. So I'll just let you do that on your own. But what I want to do is I want to focus here on these questions. So looking here at question 2, I'm going to start with this first sentence. Those who played more sports purchased blank tickets than those who played sports less. So we're looking as more sports. So as sports gets higher, the frequency of sports as that gets higher, does that lead to fewer or more tickets being purchased, or no more nor fewer, like a non-significant result there? So I can look over here at sports, and let's see, here's my input. So I'm going to scroll down until I see sports. Okay, and I see, okay, there is a relationship. It's positive. We've done this before. Looking here at the p-value, though, there's our p-value. Significant, it's below 0.05. And my beta is right here. It's a positive beta, which is why we're getting this positive slope, and it says it's a positively correlated. So this beta tells me as the frequency of sports goes up by 1 point, I'd expect the number of tickets to increase by 0.138. Okay, so I can scroll right here and look at that beta. That's what I would expect there, and that p-value there. All right. So in this case, for that question, those who play more sports, we'd expect them to purchase more tickets. If this was a negative relationship, we'd see a negative beta here. We'd see the slope going down, which would mean let's say that this was that case. Then we'd say, okay, those who played more sports purchase fewer tickets, because as sports, say this was a negative 0.138, as sports increased by 1 point, we'd expect tickets to decrease by 0.138. So let's take a look at one more for you, just for kicks. D&D, all right? So look at this here. What do you see? You see a positive relationship. Tells you that right off the bat, and this confirms it. Here's your p-value, and here's the beta. This is positive 0.365. So let me ask you, as the frequency of D&D increases by 1 point, what would you expect tickets to do? You'd expect it to increase by 0.365. Okay, pretty simple. And by the way, what type of analysis did we just run? D&D here is a number. Our output is a number. We're seeing slopes, and we're getting a beta. This very much sounds and seems like a linear regression. And if we scroll up to our overview table, we see that if our input is a number, our output is a number, we're dealing with linear regression, and our metric that we're dealing with is beta, just like what we saw. Now let's pop over to this next sentence. Looks like we're dealing with gender here. Females purchase blank tickets than males. Okay, so we're having fewer, no more, fewer, or more. So if we pop over to Stats IQ, let's go to where we see gender here, right here. Okay. This tells us there is a significant relationship. We can click here to see the p-value. P-value is 0.00000 something. So it's definitely below 0.05. So we have a significant relationship here. And if we look over here on the averages, which by the way, I saw somebody comment that sometimes I'm saying mean, sometimes I'm saying average, and they were confused by that. Means and averages, it's the same thing. Those words are synonyms. Okay, so sometimes I might say mean, sometimes I might say average. Sometimes programs use the word average. Sometimes it uses the word mean. They mean the same thing, right? Okay, but if I look here, the average for male is 3.62, and the average for female is 2.43. And because this p-value is significant, I know that this is significantly different. So males purchase more tickets than females. If the p-value was not significant, then I wouldn't have enough data to really judge this, and I'd say, okay, they purchase about the same amount of tickets. Even if it looks like the average here is different, it may not be significantly different. It may not be something you can rely on fully if the p-value is not significant. Okay, it may be deceptive. You may have a sample of 5 people and get huge differences in averages, but because you have a sample of 5 people, your p-value is going to be horrible. Okay, this one, older people purchase blank tickets than younger people. Here's age. This is a number. We already covered what happens if your input is a number and your output is a number. So this one I can give to you. Just remember, if it's a negative beta, you're doing fewer. If it's a positive beta, you're doing more. If the p-value is not significant though, it's no more nor fewer. Okay, now we got Chewbacca fans purchase blank tickets than Luke fans. So this tells me we're doing with a favorite hero. In this case, since our input is a category and our output is a number, but we have more than two categories, right? There's multiple fan bases. You got Rey, Leia, Han Solo, Chewbacca, Yoda. More than two there, and there's even more than those 5 that I listed. We know we're going to run an ANOVA. We're going to deal with averages. We're going to deal with a p-value, but also if we're ANOVAs, we're going to need to look at the pairwise comparison table. Here we go with favorite hero is my input. It's saying that there is something going on, so I click here, and I see a p-value is significant. All right. But looking here at the average tickets for each fan base, the Rey fan base, the Yoda fan base, the Chewbacca fan base, this p-value doesn't tell me that all of these significantly differ, right? I mean, look at here. We have 2.5 on average for Yoda and a 2.29 for Han Solo. Are those significant differences? I don't know. They seem kind of close to me, but I'm not sure. Rey, on the other hand, is 4.42. Chewbacca's 2.08. Are those going to be significant differences? Probably. Something is significant. Something's going on. That's what this p-value tells us. But in order to know which ones significantly differ, we have to go to the pairwise comparison table and compare them. So let me zoom out here. Look at these p-values. Sometimes I even like to just sort from here, and then automatically down here on below we have 4 comparisons that are significant. We have Chewbacca and Rey. Okay, I kind of expected that. Han Solo and Rey, Leia and Rey, and Yoda and Rey. All right, so it looks like Rey, it has the highest average, and the Rey fans were significantly higher than the Chewbacca fans, the Han Solo fans, the Leia fans, and the Yoda fans. Okay. However, there is one. If we look here, Luke. The p-value between Rey and Luke is 0.104. So this average, 4.42, and this average, 3.29, those are not significantly different. All right. So the Rey fans outpurchased all other fan bases except the Luke fan bases. And we don't really have like a clear like loser, like a fan base that purchased fewer tickets. So Chewbacca seems to be the lowest on average, but this one didn't significantly differ from any of them except Rey. All right, so we don't really have clear like loser in this case. Rey is pretty close to being the clear winner. Those fans purchased more tickets than any other fan base except Luke fan base. So from that, you should be able to answer this question here. Do Chewbacca fans, did they purchase no more nor fewer tickets than the Luke fans, fewer than the Luke fans, or more than the Luke fans? I'll let you decide. You should be pretty simple based on what we just looked at. Okay, so now as we go down to question 3, it's a similar thing, but now we're using gender as our output. So super simple. I'll let you answer this. All we're going to do is move gender as our output, and then we're going to click relate, and then see which of these inputs significantly predict our output gender. Click that. perfect. And then you'll just go through and select which ones significantly predict. Then down here, we're going to answer these following questions. Okay, so looking at this sentence here, those who played sports, more sports, were blank likely to be male than those who played less. So the more you play sports, you're either more likely to be male or female according to this data set. So if I look over here down at sports, what do I see here? That's going to be a huge hint for you. I think you should be able to answer that. I'm going to go up to these results though, because significant relationships are more interesting than non-significant relationships. So let's look at nerd worry. I'm going to click here to show the results. Here's our p-value below 0.05. That's perfect. And then looking here, I see males have a higher average than females, okay? So males were more likely to worry about looking like a nerd than females. Since our input, though, is nerd worry, looking over here at our overview table, I see nerd worry. Our input is a number. Our output is gender, which is a category, which means I'm running a logistic regression. So since we're using Stats IQ and most AI, we're going to be dealing with averages for this one and p-values, of course. Okay, so yeah, I have an average here for, of male that's higher than female. I know that's significant. Since my input is this number, I'd say, okay, the more that they're worried about being nerds, the more likely it is that they're male, because this one has a higher average than female. Popping over to D&D, another example, we have a significant p-value. Our D&D, again, is a number. It looks like males are higher than females, so the more they play D&D, the more likely it is that they are male than female. So you should be able to answer this question based on what we just covered as well. Right here, we're dealing with a fan base. So their favorite hero, does that predict gender? So looking over at fave hero, there is a significant relationship going on. But similar to ANOVA's, this p-value here doesn't necessarily tell me that all of these differences are significant. If we look at the overview table, right now we have a favorite hero as our input, and our output is gender. These are both categories. Okay, so we're doing a chi-squared. We're dealing with counts, and you can see that these are all percentages. Now with chi-squared, we're looking for arrows. So these little arrows here, we see them for Ray. We don't see them anywhere else. This arrow here, these green arrows pointing up, tell us that this cell is significantly different than what we would expect. So we have a higher proportion, because it's pointing up, we have a higher proportion of males in this Ray category than what we would expect. And then right here we have the downward facing arrows, the downward red arrows, and that tells us that there's significantly fewer females in this block than what we would expect. So these are the two cells that pop up. But to answer the question, we need to go to the pairwise comparison table as well. And the question is asking us to compare Chewbacca fans and Ray fans on how many females they have. So let's say we're going to go with males. Let's just start there. If I wanted to look at females, I could click here. But let's stay at males. They're probably most likely going to be the same anyway. If I wanted to look at, okay, for males, is there a significant difference in the number of males between Chewbacca and Han Solo fans? I'm not getting an arrow here, so the answer is no. But it looks like for males, there is a difference between Chewbacca and Ray fans for males. Right here, this is significant. So if I'm looking at Ray and Chewbacca, this is a higher percentage. So there's a higher proportion of males that are Ray fans than males that are Chewbacca fans. So I can go down and look at all of these comparisons to see which of these significantly differ in the proportion of males. Ray Han Solo, Ray Leia, Ray Luke, Ray Yoda, right? but none of these others significantly differ. Looks like Ray kind of stands out, except for with Luke, per usual, right? So Ray is significantly higher males than Yoda, Chewbacca, Han Solo, Leia, but not Luke. But if we're looking at Chewbacca and Ray, for males at least, Chewbacca and Ray do significantly differ. There's more males in the Ray category than in the Chewbacca category. And then if I wanted to look at the same thing for females, all I have to do is click female, and it'll give me those results. All right. So I'll let you go ahead and do that. Now moving on to this next question. Now we're dealing with Fave Hero. So just like before, Fave Hero is my output though. So I'm going to put the key on Fave Hero and then click Relate. You can easily go through and look at those to determine which ones are significant. In this case, when we're looking at Fave Hero as an output, it's still a category like gender, but now we have more than two categories, and not just male and female. Now we have Ray fans and Luke fans and Chewbacca fans, right? And so it's going to treat this a little bit more like an ANOVA if our input is continuous or numeric. But it's going to give us a chi-squared if our input is a category. So let's look here at this first one, SW tickets. So does SW tickets predict the favorite hero? And I click here and I see a significant p-value. Yes, something's going on. But just like we saw, actually it's exactly like what we saw because this is just showing an ANOVA. But this is exactly what we saw from the first set of questions. We see just because this is a significant p-value doesn't mean that these all significantly differ. If you can remember which ones stood out, which ones significantly differed, we see here that that Ray, if I look here at the p-values, Ray significantly differed from Chewbacca, Han Solo, Leia, and Yoda, but did not significantly differ from Luke. So Ray had Ray fans had more tickets purchased than any other fan base except for the Luke fan base. But because our input is swapped here, what we'd say is as tickets go higher, it's more likely that they were Ray fans than Yoda fans. It's more likely that they were Ray fans and Chewbacca fans, right? But it's just as likely that they were Ray fans as Luke fans. And then you could say, like, as SW tickets gets higher, is it more or less likely that they were Yoda fans versus Chewbacca? Your answer should be it's just as likely. Because if you're looking at Yoda and Chewbacca right here, the p-value is 0.9. There's a 90% likelihood that this difference between these two is due to chance. So as tickets go up, it's just as likely that they were a Yoda fan or a Chewbacca fan because that p-value is not significant. So I hope that helps there. D&D is going to be the same thing. So is there a significant p-value? Yes or no? And then look at the averages. Actually, you know what? Let's do it. I'll do that one and I'll let you do the sports one. How's that sound? Here's D&D. Significant. Here's our p-value. D&D is predicting. If I go click here and show pairwise comparison tables, what do I see? Well, those Ray fans are standing out. It's pretty much the same thing that we just saw with SW tickets. Ray is significantly different than all of them except Luke. So that's not very informative. Let's try Nerd Worry really quick. Okay, so for Nerd Worry, there's one significant difference here, and we have a marginally significant difference up here. So Ray marginally differs with this p-value of 0.07. Ray marginally differs from Leia. So we have Ray here and Leia. So Ray fans were marginally significant, but they were marginally more worried about being a nerd than the Leia fans. And then we get here to significant, and it's Rey and Chewbacca. So the Rey fans were more worried about being a nerd significantly than the Chewbacca fans. But since nerd worry is our input, we say, okay, the more that they're worried about being nerds, the more likely it is that they're Rey fans versus Chewbacca fans. And the more that they're worried about being nerds, the marginally more likely it is that they're Rey fans versus Leia fans. But Nerd Worry didn't really predict the differences between Yoda fans and Chewbacca fans, for instance, because that p-value is not significant. We couldn't predict whether they were Yoda or Chewbacca fans based off Nerd Worry. So that should give you enough context for this one as well. Now we're looking at gender. So again, if our input is a category like gender, and our output is also a category, what their favorite hero is, we're going to be looking at a chi-squared. So let's look over here, gender. Here we go. Same type of thing that we already looked at in the last example. So these two stand out. There's more male fans in the Rey category. There's fewer female fans in the Rey category than what we'd typically expect. These are significant. But now this pairwise comparison table is going to look pretty different. So this example is asking us if males are more likely to be Yoda fans and if they're more likely to be Rey fans than females. So let me pop over here. Let's try Chewbacca. Okay, I don't see significant arrows here, right? So that's telling me that Chewbacca, this 7.7% of male fans being Chewbacca, that did not significantly differ from the percentage of females being Chewbacca. I could pop over to Luke, not significant. Yoda, not significant. Is Rey significant? I'm getting arrows. So what does that tell me here between these percentages? Are these significantly different? And if so, are there more males than females? Yes. Okay, so that should help you there. If these differences are significant, then there is a difference. If they're not, then they're just as likely to be male or female. Okay, so we've gone through, we've analyzed these. We've looked at regressions and linear regressions, t-tests, ANOVAs, chi-squared. We've run through all of these that we've been doing the last few weeks, and I hope it's really starting to come together for you. Now what we're going to do is we're going to look at what these look like using AI. So we're gonna describe the data set. We're not only going to provide the data set for AI, but we're also going to describe it. It's good to give AI context to what you're doing for it to be able to run things correctly. So for the prompt, we're going to include this little scenario, and then we're going to ask it these questions. Okay, so this is actually our first question here. We're just going to replay this for AI. So you can use ChatGPT for this. You can use Grok. You could use Gemini. Some of these have free student accounts. For instance, Gemini right now has a free student account that you could take advantage of. I would do that because it's frustrating running out of prompts a lot of times when you're running these type of analyses. So beware of that. And if you run out of prompts on one, pop over to another one. That's totally fine. I just want to give you some practice using AI. So for this, I'm going to come here and I'm going to select the data set. I want to make sure that I'm giving the AI data set. All right. So I have that included there. Now I'm also going to go back to this assignment and let's feed it this scenario. Okay. And then I'm going to ask it the following questions. Which variables significantly predict SW tickets? Run each analysis independently, okay? Because a lot of times AI, it'll put all of these into one big model. We're not there yet. We're going to get to that point. We don't want them in one big model. We want it to run individual models, And so if you see it kind of putting them all together, it's not following instructions, and that's bad. But anyway, so we want the analyses to be independent, and then we want to report means, averages, or counts when necessary, and also report p-values. All right, so I'm going to copy that. I'm going to paste it here in the prompt, and then let's see what it does. All right, it's describing the data set, and it's telling me which ones significantly differ. Okay, I want to take a look. Let's take a look at this one and see how it compares. So we have Dungeons and Dragons and SW tickets. I'm just going to run this again. Oops. Just let's compare them. Okay. Beautiful. Relate. All right. So for this one, I have a p-value, very significant p-value, and then SW tickets. The beta here is 0.365. Let's see how that compares here. Now, an issue here is it's not giving me what I wanted. Okay, it's giving me R. I didn't ask for R. That's another statistic we don't really necessarily talk a whole lot about, and it's fine. But I want beta. So you're supposed to report. Maybe I'll be nice. I'll say report betas when you run linear regressions. Now let's see what it does. Okay, here we go. Okay, 0.36. So if I pop over here, I have 0.365. That's pretty spot on. Then if I look at sports, let's see what that is for me. Here's my p-value. Here my beta is 0.138. Yep, so it's rounding it, but yeah, those are the same. So this is getting it pretty spot on for us, which is nice. Gender, this one might be a little bit more problematic. See, it's giving us a beta, and I don't necessarily want it to do a beta right now because we haven't really covered it that way. So what I want to do is for logistic regression, report averages, not betas. Okay, run them again. Okay, here we go. Let's see averages. There we go. Now this is interesting because it's looking at whether it's saying that the p-value is not significant. When it is significant, so that's annoying, you know. So it's not always going to be exactly right, and I could fight with it. If it starts giving like completely bogus results though, and like nothing is lining up, start over, start on a new thread, a new conversation with it. Because once it gets dumb, it's not going to undumb itself. It's just going to it's going to try to confirm that its dumb answers are the right answers, and you know, it's going to cause like psychological stress for this poor AI if we try to, you know, have a look in the mirror. But once it's dumb and is being awful, just start a new thread. It's not worth the debate. So I'm going to try giving it a little bit more information, starting fresh. Let's see what it does this time. Oh, okay, gave me tables this time. Whatever. Okay, so if it gives you something like this, just a FYI, e to the negative 23. What that means is this decimal point will move to the left 23 times. So you'll have 0.00000. There'll be 22 zeros, and then you get 374, right? So that's very significant. The betas. This is nice. I like how it's displaying this. These are very similar to what we already looked at before. So yeah, here's my beta and the p-value. See, this is just rounding it, saying it's less than that. But GPT is giving us a more precise answer. So those are looking pretty good, at least the first couple. Gender, here's our p-value, which is significant. Average is 3.61 for males. Let's see how it's doing here. Yeah, 3.62, 2.43. Perfect. That one's looking awesome as well. So I really could go through and see which ones have significant p-values and which ones don't, right? And then that should help me out there. Okay, it did the ANOVA in 2 different tables. So you never know how it's going to display these. This is giving us the right answers though, which is super nice. There aren't really any chi-squareds to display here anyway, but anyway, so yeah, this is a little bit redundant. I don't know what all this information is. Boo. But it also has this in plain English explaining these to me. So that's beautiful. If you can get to something like this, then you should be in good shape. Look at the ANOVA. Let's see. Ticket counts differ significantly between Ray and Luke fans. Are the heaviest buyers on average. Okay, so Ray and Luke fans are the highest in the number of tickets. Let's recap that, because if you remember, it was just a little bit different than what it's reporting. Ray and Luke fans, they do have the highest averages, but if you recall, Ray fans outperformed everybody else except Luke fans. Okay, so Rays, they outperformed everybody except Luke. But if you look at the Luke fans, maybe I'll just kind of sort this to see Luke and Ray, again, they don't significantly differ. But Luke and Yoda, they don't differ. I think the rest of the Lukes are over on this side. Luke and Han Solo don't differ. Luke and Leia don't differ. Luke and Chewbacca. So when it says that Luke fans are the heaviest buyers, they didn't significantly outpurchase the others. Okay, so it's not quite interpreting it right, but it's getting close. It's getting close to the right answer, and it's just going to get better and better as AI improves. So watch for that. So this should help you out quite a bit. Once I've answered those, then I'm going to ask it the follow-up questions, the same follow-up questions that we had before. From before, we're just going to see how AI does with it. Okay, those who purchased more tickets. Those who played more sports purchased more tickets than those who played sports less. Females purchased fewer tickets than males. Older people purchased no more nor fewer tickets than younger people. Chewbacca fans purchased fewer tickets than Luke fans. Okay, so looking at these results, some of these are correct and some of them are close to being correct, but not quite correct. All right, so this isn't giving away your answers, but it did a pretty good job. Did a pretty good job as I look at this. What I would do for the answers here, I would copy, the results that you get. So I'm going to test this out, make sure it can fit everything. I'm going to copy those results and paste them here. Yeah, that's what we like to see. And then what I want you to do is explain how well those matched your previous answers from Stats IQ. So they're either about the same, exactly the same, or very different. Just type one of those here, and then that would be good. And then number 8, you're going to be looking at the gender as your input. So same thing that we just did. I can go through and copy this and paste that in for my next question here, and it'll run those analyses for us, and I can see which ones were significant predictors for gender. So you're just going to review those, put your output here, and then state how close it was from your Stats IQ. And the last one is using Fave Hero. So anyway, I hope that this assignment is again helping you put all of this together. That you're having fun with this recap using a different data set, but also that you're able to learn how to use AI. Okay, because when it comes down to it, you're probably not going to be in a job where you'll have access to Stats IQ. In fact, I saw a viral video interview with Elon Musk, and what was interesting is he predicted that within 5 years from now, software in general will be obsolete. That we'll all have some sort of device that's hooked up to AI, and we'll just say, "Hey, show me this. Hey, run this for me. Get this for me. Buy this." Whatever we would normally go to software to do, AI is just going to be plugged in and be able to do it itself, just similar to what we're doing here. So I could say, "Hey, here's this data. Analyze it for me. Give me the results, whatever." Which is exciting and scary at the same time. I hope that through this course you're learning that we need to focus on using AI as a tool and not just throwing in the data and saying, "Tell me what to do," right? That's going to be the absolutely worst outcome from this, where we become the machines and AI is the conductor. We need to make sure that we maintain that position as masters and that AI is a tool. But nonetheless, when you think about that, you look at, okay, how many of us are going to be using Stats IQ 5 years from now? I don't know, maybe that one might last a little longer than, say, some of the other software, like the stat software like R or SPSS, even Python. I don't think a lot of people are going to be using those as much anymore. Very few select individuals probably. So the most likely outcome is that you're all going to be using AI to analyze data when you have opportunities to analyze data. However, it's going to be difficult to do that if you don't have some sort of foundation. So we've gone through this overview table. We've gone through these analyses to give you a foundation to understand, okay, what does it look like when we're analyzing relationships? Why would we want to do that? What's a p-value? What does it look like when we're looking at relationships between two category variables or two number variables? What is a beta? All of these things are going to be very important for you to use in the future, regardless of whether you're using a software or AI. This information can really help give you a leg up. So I hope you go through, finish completing this assignment, have fun with it, and we'll do some more fun stuff next week.